Question number 5 tells us that a rancher has so much fencing and they want to section it off to have 3 equal adjacent rectangular corals, and we are supposed to determine the value of x and y to maximize the amount of area in each of those 3 rectangular corals. Okay, so the good thing is they gave us a picture here. Okay, so these 3 are all supposed to be equal. So whatever this length is, this length has to be the same, this length has to be the same. Whatever this width is, this width has to be the same, has to be the same, has to be the same. Okay, part A wants us to write the total area of all the corals as a function of x. All right, well, all of these is one big rectangle. Area of a rectangle is just length times width. And it looks like my length is x plus x plus x, 3x. And my width is y. And now it's tempting to circle that as our answer, but that's not going to be good enough. It says that we need to do this as a function of x. So this right here is a function of x and y, not just x. So this is where the 600 feet of fencing comes into play. So I can also think of the parameter, which is like the distance, kind of like the distance around a figure. So I have an x, 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 y, x, 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 y, but then also another y here and another y here. So in total, that was 6 x's and 4 y's. So 6 of these links and 4 of those links ends up being my fencing I need to use. And for this question, they say that is 600 feet of fencing. And this gives me an equation that I can now solve for y. And it looks like y will always be 600 minus 6x all divided by 4. Well, plug that in up here. So I've got 3x times the quantity 600 minus 6x over 4. And while that may look messy, now it is an area in terms of x because it only has x values. All right, for part B of question 5, it wants us to use our graphing calculator to graph the area function. So I have gone ahead and typed this in. To be safe, I should probably put parentheses around my fraction though. Okay, so it wants me to graph this and then find the exact value of x that produces the maximum enclosed area. So graph. Now what I anticipate is that I'm probably not going to see anything, and sure enough, that's what happened because the numbers are probably a little bit bigger. I mean, I have 600 feet of fencing. I doubt that the amount of fencing that I would use for x would be somewhere between 0 and 10. Pretty unlikely. So I need to either manually adjust these x and y values in window and do a little bit of guess and check to make it look right. Can also zoom out a few times, and that doesn't necessarily look great. If you go down far enough, you can find zoom fit. And this is where your calculator tries to make a good guess for you. And that's okay. I mean, I can at least see it now, but I can't really see where the max area is. So now I'm going to go to the window and say, okay, go a little bit further to the right. And I honestly have no idea. I'm just trying to make an estimated guess. Okay, so I can see the area is still going up, so that wasn't enough. Looks like I might need to go further to the right, but I can tell I also need to go further up. And again, I don't really know how much yet, so it's a little bit of guess and check. Try something. Okay, that made it worse. Oh, because I made this 5 instead of 50. But for that matter, I know that the length's not going to be negative, so let's go ahead and change that too. Okay, getting closer. Go up a little bit more. Go up a little bit higher. There we go. Okay, so since this is an area function, as x gets bigger, the area gets bigger for a while, and then at some point, a bigger x gives you a smaller area. So this is where the area is maxing out. Now, I will say one thing I really don't like about this approach is you can see that it does take some guess and check. I didn't know the right window settings to use, and that was all just to figure out what the picture looks like, or the parabola looks like. So I still need to actually find that x value. If we go to second trace to pull up the calculate menu, we can go down and say find a maximum. First question is going to be left bound, and you need to make sure that you move your cursor to the left of the maximum before you hit enter. It should change to right bound, so move your cursor far enough that you're sure it's to the right of the maximum before you hit enter. You can put in a guess if you have a guess. That speeds it up sometimes. And then it goes about finding the maximum for us. So the algorithm that it uses creates a little bit of error sometimes. So it's not really 50.000006. It's really trying to say 50. So when x is 50, we have our max area. So that would be the answer to part B. All right, to finish up, part C, give the maximum area enclosed. Well, if this was our area function, here or here, and what we now know the x value that gives us the max area, I guess you could plug 50 into this and see what you get, or you could plug 50 into this and see what you get. Or just remember that this graph is graphing the area function. So my y is actually my a. So when x is 50, y is 11,250, and that would be feet squared. And so that's already done for us. Now again, for a second time, I'm not crazy about this method because it is a little time consuming, especially if you had something like this on the ACT. Even if you know what you're doing, you're kind of not being very efficient. So you may also pay attention that this is going to be the vertex. The max and the min, if the parabola opens down, the vertex is a max. If the parabola opens up, it would be a min. So an algebraic way to find the vertex is 90% of the time going to be a more efficient approach.